hope you can see the screen. So in our last class, we have discussed about the different types of motions. We even have discussed about the time and simple pendulum. I hope it's clear. This topic was clear to you. And the different types of motion. So the different types of motions are the translatory motion, vibratory motion, and rotatory motion. So in this also there are different types. So the types of motion are the vibratory, linear motion, curvilinear motion, circular motion, oscillatory motion, rotatory motion. So these are the different types of motions which we can see. So firstly, we'll discuss about the translatory motion. I just 1 second. I'll make it a little bit big. So we'll discuss about the translatory motion. So what is translatory motion? It's a type of motion when the motion of a body is said to be translatory if the body changes its position with respect to fixed point or its surroundings. So we have discussed it in our last class about translatory motion. An object is said to be in the translatory motion when an object is moving in a straight line or when it is moving in a circulatory path. We've seen the example of a car which is moving in a straight line. So at times it has to slow down. It depends on the traffic. So it is to be, okay, just 1 second. I hope she's already there. Okay. Because I'm sharing the screen, so I can't be able to see who are joining. Thanks for informing, children. Okay, so we have seen the example of a car which is moving in a straight line, and even it is following the translatory motion. In translatory motion, the particle moves from one point in the space to another. I want any one of you to read this from the beginning. Motion. One by one, you can read. Neha Darshi can start.
Ma'am, after Neha Darshi, I will, ma'am.
Okay.
Ma'am, after Smritika, I will.
Okay, what about the children who have joined? They have the textbooks? I mean the course.
Ma'am, after Nimira, I will read, ma'am.
Okay. Do Sanjana, Rishita, Krishna Kaushal, do you have the course books with you?
Yes, yeah, ma'am, I have.
Okay. I just want to give the chance to those children who were not there in the class. Yes. Rishita, you can read out.
Ma'am, should I read or Rishita?
Ma'am,
Rishita.
Ma'am, wait a minute, ma'am.
Yeah.
Ma'am, wait a minute. Ma'am, can you say the page number because I was seeing your
Page
screen
18.
only, ma'am.
18.
Page 18. Yeah, ma'am. In the physical world, one of the most common phenomena is motion. The branch of physics which deals with the behavior of moving objects is known as mechanics. Mechanics is further divided into two sections, namely kinematics and dynamics. Kinematics deals with the study of motion without taking into account the cause of motion. Dynamics is concerned with the cause of motion, namely force. There are three types of motions: translatory motion, rotatory motion, vibratory motion. Translatory motion.
Thank you. So we have discussed this about the different types of motions and what is the study of motion called as. What is the study of motion?
Ma'am, what ma'am? The study of?
Motion called as.
Study of.
The study of motion, ma'am.
Yeah.
I think it is what we call
Ma'am, phenomena.
Kinematic. It is,
one, ma'am.
kinematic deals with the
Is it
study of motion.
kinematics?
It's
Kinematics.
kinematics, ma'am.
Kinematics. And what is meant by dynamics?
Means
Dynamics,
it
it
is
is,
only
ma'am.
to how the motion will
It
be
is
conquered with the cause of only
It is conquered with the
It
cause
only
of
like,
motion,
it
namely
only
force.
deal with the cause of the motion, ma'am.
Yes, ma'am. Namely,
So deal
force.
with force.
Physical
Like the
factors,
force.
ma'am. It is related to
The
physical factors.
dynamics is
Like
Like force,
concerned
It
with
is
the
like
cause
concerned
of
with,
motion, namely force.
force,
yes,
mass, energy,
yeah,
and also momentum.
okay,
Mechanics, ma'am.
okay. So dynamics is concerned with
Ma'am,
Cause of motion,
I
ma'am.
have
force.
a doubt, ma'am.
Yes,
Ma'am, vibratory motion is also known as oscillatory motion, ma'am.
yes. I think my voice is coming a little bit late to you.
No, ma'am, it's that. Okay, ma'am. It's not like that.
Okay. Yeah, who'll read out the next one? Translatory motion.
Ma'am, can I read, ma'am?
Yeah, I'll give you the chance. Yeah, Krishna, read. I want
Okay,
Krishna
please, ma'am.
to read out.
Translatory motion. The motion of body is said to be translatory if the body changes its position with respect to a fixed point or its surroundings. In translated motion, the particle moves from one point in a space to another. This motion may be along a straight line or along a curved path. Motion along a straight line is called a
Rectilinear motion. I want you all to look into your book and read.
Motion along a curved path is is called a curvilinear motion. Examples
Okay.
of translatory motion.
Okay,
It-
Krishna Shri. Yes. So here we have discussed about the translatory motion. What type of object show, the motion showed by an object in a straight line. If an object is moving in a straight line, it is said to be moving in a translatory motion. It might be a straight line or it might be in a curved manner. If it is moving in a curved manner, then it is said to be moving in a curvilinear motion. When it is moving in a straight line, then it is said to be moving in a rectilinear motion. Yes, Shreya is raising the hand. Yes, Shreya, you want to read?
Yes, ma'am.
Okay, Shreya, you can continue reading the examples.
Some train running on rails, can I read, ma'am?
Yeah, you can read.
A train running on rails always runs either in a straight line or a curved path. A car changes direction when it takes a turn at an intersection. A swimmer dives into the swimming pool from the dividing platform, taking a curved path, since his direction at each and every point on the diving path is different.
Okay. So these were the examples of translatory motion. Like a train moving on a rails always run either straight or in a curved path. And a car changes its direction whenever it have to take a turn at an intersection. So while showing the translatory motion, these objects, they show even the curvilinear motion also, like the train and the car. While if we see the examples of rotatory motion, so they have to rotate, they follow only the rotatory motion, they can't even change their position, like in the translatory motion. In the translatory motion, objects even follow rectilinear as well as curvilinear at times, depending on the position in which they are moving. But in the case of rotatory motion, the objects, they have to show only one type of motion, isn't it? Yes. Can Snitika read rotatory motion?
Rotary motion. The motion of an object is said to be rotatory if the parts of the body describe concentric circles about the axis of motion inside the body object. That example of rotatory motion. The blades of ceiling fan are fixed to the body of the fan, and of the top will not change its position. But the body rotates about its minute and second. Hands of a clock rotate about a fixed point.
Okay, Snitika. Thank you. So this was about the rotatory motion. So examples of rotatory motion are, just one second, I'll just show it to you. So the spinning motion of a body about its own axis is called rotatory motion. The examples for this is a steering wheel of a car and a wheel of a bicycle. They show rotatory motion, and even the fan, which you can see in your house, they show the rotatory motion. So the motion of an object is said to be rotatory if the particles of the body are moving in a concentric circles about its own axis. An axis is a line around which a body rotates. It's a line in which the body rotates in the same direction, isn't it? So, for example, the motion of the wheel and even the steering of the wheel of a car. So, even a few examples, if you know, you can even tell a few examples of rotatory motion. Yes, can anyone? Examples of
A giant wheel.
I say
A giant
Yeah,
wheel.
ma'am.
Yes,
A
good.
giant
Giant wheel. Yes,
giant
wheel.
wheel,
And
giant wheel.
and
Like
few more.
how
And,
the
cycle tire.
Yes,
and the vehicle tires, the ceiling fan, how it will go, the ceiling fan, ma'am.
yes, the ceiling fan, and a few more examples if you can give.
Steering wheel.
Ma'am, we can
Yeah.
even say the motion of the planets.
Ma'am,
Yeah,
it-
ma'am. The
Rotation
Earth,
motion.
rotation and revolution of the planets
Earth
and
rotation
planets,
about
ma'am.
its own axis around the sun.
yeah, ma'am.
ma'am.
Rotation and revolution.
Yeah.
Ma'am, can I say one more?
Yes.
Wheels of the car, ma'am.
When
And
we
steering
drive a
of,
car,
steering
the
wheel of the
steering.
car.
ma'am,
Yeah.
Rotation motion, the steering.
ma'am,
Yeah.
can I say
Ma'am,
one
the
more?
steering cycle and sun.
We have already
And the clock, ma'am.
Ma'am,
Yeah.
also
A clock.
spinning top, ma'am.
A clock.
Yes, a clock.
moves-
Yes,
goes in a
ma'am.
rotation.
A
Yes.
clock also.
Yes, a
So,
also, and
Ma'am, even the
What
giant
else?
wheel.
a
ma'am,
spinning
also
top.
merry-go-round.
A spinning top.
Yeah, ma'am. Merry-go-round.
Ma'am, also a merry-go-round.
Yes, a merry-go-round, and a few more. If you can tell.
Like how the hands of clock, ma'am.
Yeah, the hands of clock also.
What else? What else? Revolution,
And as well as
rotation
wheels.
and revolution.
Even you can give an
planets,
example
cycle,
of.
we already said that.
Even you can give an example of windmill.
Yeah, ma'am.
The
Windmill.
windmill goes round and round.
So this was about the rotatory motion. There are so many examples of rotatory motion which follow the rotation, which move in an axis. Even the planets
Circle
also.
path.
Yeah. So now about oscillatory motion. I hope we've already discussed about this
Should I
oscillatory
read,
motion.
ma'am?
Yeah, you can.
Ma'am, can I read, ma'am?
Yes, ma'am.
Yes.
The motion of an
Read it out.
object is said to be in oscillation. Okay, ma'am.
Yeah,
Yes,
continue,
ma'am.
continue.
Yes, ma'am. Oscillatory motion, ma'am.
Yeah.
Nehita, you can continue.
Nehita, continue.
Oh, yes, ma'am. The motion of an object is said to be oscillatory if the object moves to and fro, back and forth. From it means position. Examples of oscillatory motion: the pendulum of a wall clock oscillates to and fro from its mean position. A swing oscillates to and fro from its mean position when someone swings it.
Okay. Yes, you can even read, Nehadarshi.
Yes, ma'am. I bought these examples, ma'am.
Yeah.
Yeah, ma'am. Examples of oscillatory motion. The pendulum of a wall clock oscillates to and fro from its main position.
Mm.
It oscillates to and fro from its main position when someone swings it.
Yes. So these are also called as oscillatory motion. Vibratory motion can also be called as oscillatory motion also. So the motion of an object is said to be oscillatory if it moves to and fro, isn't it? Even the image you can see on your screen about the pendulum of a wall clock, it moves in a to and fro manner. Even the swing also. So
Yes, ma'am,
these are
the
the different
spring.
types of motion which we have learned. I hope it's clear to you. Just give me 1 second.